Thank you. So, yeah, the title comes from a really horrible movie, The Girl Next Door, where I think this quote was probably the most useful thing out of the entire movie. But when I do talks on DNSSEC, almost inevitably, what it really boils down to for most people is, boy, that seems like an awful lot of effort and trouble and pain. Do I get anything useful out for that? So I'm going to talk about some of the benefits you get and give hopefully a fairly balanced view on what the pain points are and how to cope with them. So what do you actually get out of DNSSEC? So probably the thing that drove DNSSEC first into popularity at all was the Kaminsky attack and cache poisoning being proven to be almost trivial. And obviously, if you cannot trust what's in the cache of a large recursive server, you're effectively able to man in the middle everybody who uses that cache, and that cache becomes at risk. Second, we're doing all sorts of things with DNS beyond simply converting names to numbers. There are all sorts of things that have built-in trust and other things that we have overloaded on DNS that it wasn't really designed for, but where it's really critical to know that your DNS, the answers that you get are what the zone owner actually wanted you to get. Another one, and we'll talk more about why this is useful, is we're definitely getting into the point where we are using certificates very widely for various forms of encryption, and certificate authorities, CAs, are not always the best choice. So UDP is designed to be an unreliable or at least rather cheap protocol. It's trivially spoofed. Cache poisoning is relatively trivial. Cache poisoning is dangerous. And we are really unable to, at scale at the moment, convert to TCP for everything, or to use tunnels or encryption or various other tools that we would normally throw at a problem of saying, how do I trust something where it's very hard to tell where the packet came from? Data integrity. I mean, you have to know that you're getting it. You want to know that if you're going to your bank's website, that it is actually the IP address of the machine that is the web server that your bank owns, operates, and is responsible for. I talked about use of DNS. A lot of things like anti-spam use the fact that a DNS record does not exist as a decision point for doing something or not doing something. Therefore, you need to not only know that this is the record that the zone owner had, you need to, by the same assurance, be able to say the zone owner says authoritatively and can be proven cryptographically that record does not exist. And you need to be able to do that through an entire chain where you know it's not just this piece of the puzzle that works out, but from the point where you start your trust anchor, where you say, I'm willing to make this one single leap of trust all the way through to the answer I got, I can cryptographically prove that this is indeed what I got. So, one of my favorite subjects, CAs. Last I looked, this number may not be completely accurate, but if you go through what's actually configured in all the popular browsers and all of the CAs that they trust, there are approximately 1,300 organizations that are allowed to create certificates. And you are effectively trusting 1,300 organizations, many of which you have never heard of. They can sign any domain. There is no hierarchical structure that encompasses above the CAs. Each one essentially can start at its own equivalent of a root. And the rigorousness with which they check things, there are some that will ask for incorporation papers and a fax of a driver's license. There are others that have the incredibly rigorous test of, did your credit card process the $15 fee correctly? So the analogy I would use is that DNSSEC and the leap of trust, it's kind of like going to your family reunion. It's a pain in the ass, but it's not exactly what you chose. But you're going to go anyway, and at least you know what you're in for. Certificate authorities are more like you're going to a college reunion, and you call up your old college roommate to see if he can get some weed, and he knows a guy who knows a guy who knows a guy. So,
no idea what you're talking.
so as far as self-signed certificates and using the DNSSEC and the DNS tree to validate, you're already trusting that A record. So there is an argument that says, oh gee, the root key and all of that, how can you possibly trust that? To which my response is, how often are you typing IP addresses instead of domain names into everything at the command line and in your browser? And how many IP addresses do you have memorized? So if you're willing to believe that the bank's zone says this is the A record that corresponds to your bank's website, and you're willing to actually go there and type in your credentials, a certificate that your bank puts into DNSSEC is essentially no additional leap of trust. So if you're willing to go with that, what do you actually get? Probably the biggest thing is DANE, which is essentially authenticated certificates or information embedded in a DNS record. It's most commonly used for things like email and for setting up TLS for exchange of email. You can use it with web browsers. Currently, the large, Chrome, Firefox, and Safari are not willing to put it in as a primary check, but there are plugins that you can use. So you can use DANE certification instead of using the CA cert chain. There have been implementations of Jabber. There have been implementations for SIP and VoIP. Effectively, all the places where you would expect to see certificates. There is a development effort. The GetDNS API folks are trying to come up with programmatic ways of doing DNSSEC validation, certificate checking, DANE, and the rest of it in a way where it's a simple API call so that people that are not DNS experts can still get all of the benefits. The website has information on where to get the code and what progress they have made. Okay, so that's in theory what you get. What is it going to take to get this up and running? So the biggest thing is cleaning up your DNS. The DNS you have now has things you need to fix that DNSSEC will not be happy with. And then I'm going to break down issues with the authoritative servers, i.e. zone owners and signing of zones and serving signed data, and then the recursive servers which do the validation. In DNSSEC, you cannot have authoritative servers validating. You cannot have validating servers being authoritative. So, cleanliness. DNS took the John Postel, be liberal in what you accept, to bizarre lengths. We have things that work kind of, sort of, most of the time, amazingly in spite of drastic breakage. That in theory is a feature, but it means that we have been obscuring all sorts of failures that have been working for years. Things that never were supposed to be even in classic DNS. Dotted hosts, where you have a foo.bar in example.com instead of having bar.example.com being a clean zone cut. Mismatches in what you have in the child and the parent as to the delegation and the name servers, the glue records and the NS records. Doing cute little tricks like having your recursive server being authoritative for certain zones instead of doing forwarding or something else outside of the recursive server. Views where the same label will have a different result depending on some rule like where you came from, what IP address you queried, etc. NX domain rewrites, various other forms of commercial lying and or content filtering. Response policy zones, RPZs, where again, you're not giving the one true answer. So I like to think of DNSSEC as kind of like Wonder Woman with her golden lasso. It essentially says DNS, we're not allowed to lie anymore. It's not totally true. It's probably more like lying to our parents or our spouse. Occasionally it's the right thing to do, but you shouldn't do it casually and you should do it very carefully. So, authoritative servers, what are the things that you're going to deal with? So, First up, after you've done the cleanup of your DNS infrastructure and it's actually back to being RFC compliant in all ways, there are a lot of choices that you have to make in terms of what and how you're going to sign things. For ZSK, zone signing keys, the things that sign the records within the zone, and key signing keys, they sign the zone signing keys. There are key size and expiration dates, which are sort of interlocked. It's essentially when you expose a cryptographic secret, the more bits you have, the longer it can be exposed, or the more exposures, i.e. records, you can have before it's cryptographically at risk as being more easy to crack. So you need to do that balance. You need to figure out what algorithms you're going to sign with. There are different algorithms that have different strengths. There are algorithms that have different sizes of keys for the same cryptographic strength. TTLs become very important because if you have certain parts of the validation chain cached much longer than others, and you're trying to change your keys for an invalidation or a revocation or to roll new keys, you are now at the mercy of those longest TTLs. So you may discover that because of the way you did things, it may take you 3 months to revoke a key and make sure that you're not breaking DNSSEC. You need to think about all of those. How you roll over the keys will have a big effect on how big your zone files are. That may be an issue. NSEC and NSEC3, next secure record, these are the cryptographic means by which you prove that things don't exist. And there are trade-offs with which of those you use, depending on what you're more concerned with. The biggest secret with DNSSEC and doing all of those things, once you've made that decision, automate. This is like in the days when I was doing IPv6 and talking about IP address management schemes. Anybody who hand types 32 hex characters is going to drive themselves insane. DNSSEC is another. If you think that you are going to control keys and roll things and shuffle zones around and not screw it up, I applaud your enthusiasm and optimism. The issues. The biggest things, so my day job is at Comcast. We are validating approximately 10% of the public DNS queries on the internet. We and Google are about the same size. We have been signing all of our public zones for 5 years, at least much of them for 5 years, and certainly in the last 3 years, all of them. We DNSSEC validate everything. So what we have mostly seen on our auth servers is use of the DNSSEC as an amplification attack. We have seen issues where people blow key rollovers because they are either doing it by hand or there's a bug in their rollover automation. And there are interesting complications when you start having to deal with zone transfers and dynamic updates. You have to decide what is the actual one authoritative master and how you insert new records and how things get signed and re-signed as you change that zone data so that all of the chaining works. And there are system capacity issues that you need to start thinking about if your systems are a little older. So amplification attacks, if you're an authoritative server, you actually get to pick the algorithm. So you can look at things like ECDSA, which has a slightly higher computational expense for the recursive servers who are validating, though not huge. I can give you a reference study if you're interested. But there is some, but the keys are significantly smaller for the same strength than RSA, which is what everyone was using. You can be a good network citizen by rate limiting, particularly things like any. Doing any of a DNSSEC signed Apex will usually get you a 2 to 3K packet as your payload for a 60-byte query. That's a pretty scary amplification vector. Most, if not all, DNS servers that I'm aware of have some kind of minimal response. We used to decide that it was very helpful to add a bunch of records so you didn't have to do multiple queries. We're discovering instead all that means is that you're sending stuff that they are going to have to ask for and validate anyway if they're validating, and it makes the packets bigger. And log everything that you possibly can so that you can possibly discover it before it gets too bad. Key rollovers, again, validate and monitor to make sure that you are not suddenly not validating. We have had some very unpleasant surprises on some key rollovers. Most people who are doing this will have some form of hidden master, particularly if they're doing DNS updates, something that isn't one of the listed NSs. The nice thing about doing that is that if you have one single hidden master, you have one place to sign and re-sign. The downside is that it is not redundant. Multi-master is hard anyway. Multi-master and DNSSEC signing is even harder. I know of no vendor that does it without occasional blips. Some are better than others. If you can get away with it, sign it in one place. System issues, whatever is signing is going to have to do crypto math. So not only will it need a CPU that's sufficient for doing that, the biggest problem I've seen is randomness. If you are running on a VM, most of the things that are used have to do with hardware. And so you are going to need a separate hardware randomness module. And they are available and they can plug into USB ports on the tenant machine. You just need to be aware of that and think of it. Otherwise, what happens is the cryptographic generation winds up being tens of minutes as opposed to seconds. And zones are way bigger. So figure that out in your disk space, particularly if you have very large zones. So validating servers, many of the same problems. Amplification in DDoS. The big one that everyone touts is somebody else screws up somewhere else on the internet and you get blamed. And it's not your zone, so you can't fix it. Those lead to the next two, which are user and staff training. Have documentation and training available for your customers, for your staff to go through. So for amplification, obviously, whatever you can do in BCP 38 or 84 or source address validation, whatever you're using, if they can't spoof the package, you at least know who. Comcast on all of our broadband has source address validation in DOCSIS. We have lots of customers that are hacked and malwared and participate in DDoS attacks. But as soon as they start doing that at volume, we have logging on our validating servers, we notice it, and we can turn them off because we know exactly who it is. ACLs, so that non-customers can't use it, don't run open resolvers. Response rate limiting can be a useful tool. It is not a panacea, but it is certainly there. Minimal responses is also something you can set in recursive servers. Don't send more than you need to. And of course, log everything that you possibly can. The more you notice, the more proactive you can be. We have on order hundreds of billions of queries a day at my day job. We DNSSEC validate everything. We have 26 million customers generating those hundreds of billions of queries. We have, on average, 3 to 6 incidents a week where we have to figure out that somebody's DNSSEC is broken and try and get it fixed with them. That is so infinitesimally small, it is ridiculous. But what we see, pretty damn common every time. Someone turned on DNSSEC by mistake. There's, like GoDaddy has a checkbox that says, do you want your DNS to be secure? Ooh, that sounds good. Tick. They have no clue that they have now enabled DNSSEC and that they need to keep it working. Which is great for the first year until the key rollovers blow because of some bug in the GoDaddy script. And now Comcast is filtering my website. That's usually the complaint you get. Expired keys due to bad automation. Someone goes, what the hell is this thing in the registrar record, this DS thingy? We don't need that. Or what's all this crap with this RR-sig gobbledy in my zone file? I can delete that. And suddenly one half of the equation doesn't validate. So usually key rollovers or gross ignorance on the part of the zone owner. There's an RFC 7646 for negative trust anchors that explains why you should go through and investigate and try and contact the zone owner and the rest of it. Explain to them why it's not us blocking them, they've actually done it to themselves, and that it's not just Comcast, it's Google, it's anybody who validates, it's all the US government, etc. It's very hard to get to them. It's very hard sometimes to explain to them that we're not breaking it, that it is them that needs to fix it. There are things like negative trust anchors if they absolutely know their means, but we've had pretty good luck. That's another. We usually have 24 negative trust anchors for the entire internet, half of which are .gov and .mil, and half of which are there long-term for us, because we have pretty much come to the agreement with them that they are going to insist upon doing it wrong, or we have never found anybody with a pulse. But in most cases, we at least try, because maybe it was something. It's very hard to not know initially that it isn't a downgrade attack rather than a mistake. And so you don't want to take away someone's DNSSEC protection where breaking the zone is actually the correct behavior. So it shouldn't be done lightly, but the RFC does break down when you should and shouldn't. Not your zone. Even when you get to them, it's hard, but it's very hard to reach people, and I'm sure we all know that the Whois database is spectacularly accurate and completely up to date and completely useful. And some .gov doesn't even have a publicly available Whois server. So we have to send mail to dotgov.gov and say, hi, this zone is broken, and hope that they can find somebody for us. So we have a little Rolodex that we keep on our NOC web page of contacts, and that turns out to be disturbingly handy. There is a program called DNSViz, dnsviz.net. It's spectacular. It breaks down in a graphical format exactly what's wrong. One of the other things I love is it's not my website. It's not even on my network. It's owned by a completely different company that I have nothing to do with. It is a neutral third party that is telling the person I'm calling that their DNSSEC is broken, and it's not just my folks saying it's broken. And you can save the output. You can have them run it. You can email it to them. You can put it in the ticket for record of what was broken. Good stuff. Hopefully you can get them to actually admit it and actually fix it. That's a lot of the user training. You send them there. It has a lot of good information. ISOC has the Deploy 360 webpage that has a lot of good information, and we have sent a lot of folks there when they go, oh, that's what that secure DNS thing is. Where do I learn about it? We send them off. And we have some pre-done text of certain types of things explaining, so that we don't have to every single time redo all of it. So there's a lot of education of your customers. And your tier ones. You know, they are not our engineers, but they are the face of your company. The more tools and information you give them up front, and the better and more correct a diagnosis they give before they escalate to the engineers, the better you look. And the better the information to you when they drag you out of bed at 3 o'clock in the morning. So, all worth doing. So, ultimately, is it worth it? Well, you should be cleaning your DNS anyway, because there are all sorts of other breakages you probably aren't noticing that are probably affecting response times, web page loads, and a bunch of other things. Or you are one web server away from dying and you don't know it. DDoS is a problem for all of us. And you can do it with text records, A records, all sorts of other things. So all the mitigations that you can use for DNSSEC, you should be doing right now for everything else. Cache poisoning is really bad, and right now DNSSEC is pretty much our only protection. And once you've done the initial work to automate what you need to and to train, as I've said, 3 to 6 incidents a week, less than 4 hours total for me, a staff of 10 engineers, for 26 million customers. I think that's a pretty trivial amount of time. So, questions? Oh, yes. Yes. There are cheat sheets available printed, by the way, by Kathy at ISC. So if you would like to pick those up while here, please do.
Hi. Various people online, must be true, complain about DNSSEC, and there's 2 things that come up that I'd just be interested to hear what you say. One of which is that it's riddled with 124-bit RSA, which is not strong enough. That's the contention. And the other one is that because you can chain certificates, you can do a zone enumeration, which as an enterprise we don't want. So I'm just interested in what you say to both of those.
Right, so RSA, yes. The RSA algorithm is fairly large, and that's one of the reasons why amplification vectors are more impressive. That's why I'd mention ECDSA as an alternate algorithm for doing your signing. You get a much smaller, whereas you would probably get 1,500 bytes for a certain level of RSA, you can do the same thing in 400 to 600 bytes in ECDSA.
But if the top zones are signed with RSA 1024, then the whole thing's insecure because that's not cryptographic.
That, okay. No, this is the web guys looking for an excuse to not use DANE because they are all using 2K keys. Key size is only relevant in terms of exposure. The root zone has a very small number of records that it signs fairly infrequently. So a 1K size is fine. If they were enumerating and re-signing millions and millions of records every day, the number of potential collisions that you could study and therefore reverse engineer the key goes up, and yes, in that case I would want more bits. That's the relationship between lifetime and key size.
I'm not sure I understand it. Actually, longer lifespan is worse for a shorter key
well,
because you have more time to crack it.
Yes, if either you have less bits, you need to make sure that your lifetime is not too long. If you have more bits, you can go longer. But it's not just longer, it's either longer or the number of signatures you have made with it that are exposed.
And so the second one about chaining.
Sorry, can you repeat the second?
Enumeration of
yes.
zones,
So NSEC allows you to go record by record by record. The TLDs objected to that, and that's specifically why NSEC 3 was invented. NSEC 3 has 2 hashes instead of records, so you cannot enumerate the zone. Now, there have been some folks that have been doing some math and pushing for NSEC 5, claiming that they can cryptographically reverse engineer the NSEC 3 and actually enumerate the zone anyway. But the reality is the amount of data they have to get in order to be able to do that, you would notice somebody doing that many lookups to you and it would show up in volume.
So is the recommendation NSEC 3 and not?
If you don't want enumeration of zone, NSEC 3. My personal feeling is just allow zone transfers anyway, because that's vastly less efficient or less abuse on your server than doing record by record enumeration either way. But that's my personal opinion. I understand why some people don't do that for business reasons.
Yeah, Ray Bellis, IFC. The root keys are in the progress of being migrated to a larger key size anyway, so I think at least 2048 bits.
Yes, and that's another, and they're doing that actually specifically because we're trying to promote DANE and we're tired of having the web guys going, all of our stuff is 2K and yours is less secure.
Well, the root key size is increasing at the end of September.
Right, but that's one of the main reasons, yes. And that it hasn't been rolled in quite a while, but yeah.
It's 2K, I think, isn't it, Keith, from memory? I think it's 2K they're moving to.
That's what I recall as well.
Hi, David Growth at Sky. You said about 6 a week people break their zones. How many people do you defend against actual baddies by validating?
That one's harder because if you sign the zones and it goes in and your cache is never poisoned, unless their cache poisoning attempts, well, first of all, if they're cache poisoning and it's signed, they're stupid because it's pointless. And it's pretty easy to check before you fire off your script. Secondly, at our volumes, it's somewhat hard to detect levels of queries. We have to get into almost a level of our customers querying www.google.com before they show up in our radar as enough queries for us to worry about. Everybody has their own threshold, but yeah, when you're into hundreds of billions of queries, somebody doing 50,000 queries a second is noise.
Okay.
So it's very hard to sell DNSSEC in large organizations because I've tried to do it twice. I mean, I worked 10 years at Amazon, mostly in the DNS team, and now I work for Facebook. And the argument is, firstly, like, it's a ton of work, particularly to clean up your DNS when you have a lot of it. You don't get last mile protection, which means your customer can be spoofed between them and their ISP's resolver. And the biggest one really is most of them, certainly what Facebook would argue, as would, I mean, most have CDNs, which means they like giving different answers to different people based on where they are. And the last and most wonderful was like, well, we have SSL. We expect everyone to contact for SSL. When Amazon made this argument, as does Facebook, like, we have SSL protection already. The only thing DNSSEC really buys us is our customers not being able to get to us. And that doesn't seem to be a strong enough argument for anyone to say, I need to commit a bunch of people to do this. But how do you change that perception? Because I've never been able to do it myself, and I've had those arguments many times in both organizations.
Right. Well, your business model and what your risk that you're trying to mitigate all change things. Facebook is an interesting one in that there's a very limited number of things that you actually want to be able to get to work. You want www.facebook.com to absolutely positively work and not be spoofable. There is no reason to not do signing so that other people validate. That's relatively straightforward and relatively clean. So you can at least get your entry point secure so that large providers or people, because a lot of countries these days are using Google rather than running their own because it's free and it works better. So there's a fair chunk of the world that is actually now validating for free. As to you validating at Facebook, there's a lot of arguments to be made that it's probably only useful for you in your IT infrastructure, not in any public infrastructure that you might be offering. And you might choose to do it, and that's what we're doing internally right now, is we are NTAing or giving negative trust anchors for a lot of things and only validating internally stuff that we absolutely want to work that point to things like our timesheet and other critical infrastructure. So make a more surgical decision of where to do it. The advantage to that also is you're lowering the risk of what will break. You're getting the maximum benefit for what you will be protecting. And you're also then having an existence proof that it wasn't nearly as bad as they said it is when you roll it in. And so then getting a wider deployment once you got your foot in the door becomes a lot easier.
Thank you.
Sure.
Okay, two more questions and then it's time to break.
Bert first. So I'm going to say some horrible things. So I'm Bert Hubert of PowerDNS. Paul gave a description of what I would call luxurious DNSSEC in the way you should be doing it, with separate signing pipelines, automated key rollovers, proper NSEC, NSEC 3. There is a middle ground. And there is a middle ground where you say, look, I care about DNSSEC, some of my people care about DNSSEC, I want to have the signatures, I'm not going to go all nuclear launch code on them. In PowerDNS, we made that the default because we diagnosed that there would be a lot of people that said, well, I'd like to do DNSSEC, but I'm not going to do the whole signing pipeline with a hardware security module. So one mode that you can do is say, well, PDNS util secure zone, and you are actually done. That's good. What's bad is the signing key is actually on the server. By the way, just like your SSL key, which is also on the server.
Yes.
If you turn on NSEC 3 in narrow mode, it will do some slight lying and solve the enumeration problem for you. Now, there are purists that would say you are not doing proper DNSSEC, which is to some respect true. But the good thing is 99% of people will say, hey, well done. Thank you, you're doing DNSSEC, and you actually made the life of attackers a lot harder. So I would commend Paul for clarifying the way you do the whole thing with the key rollovers and stuff, but the vast majority of actual DNSSEC users have never rolled a single key. And they're still quite good.
Yes. And yeah, let me follow on with that. Is yes, providers have their own rollovers, and several of the open source implementations. Bind has automated NLNet's NSD uses OpenDNSSEC to do it. So there are tools. If you want to have all the decisions done for you and take a packaged way of doing it, but you still do have to make sure, and there are occasional bugs, and that's, like I said, that's what we've seen. So you do need to be aware of what's going on under the hood. But yes, the state of the art has improved vastly in doing it without having to be a DNS expert.
Jim Reed, two quick comments. Paul, first thing is that your issue about training, I think, is a very important point that has to be made, particularly for people that are handling support calls. You need to be able to tell the difference between a regular serve fail from the DNS as opposed to a serve fail called by a validation failure, yes. And that sucks. An additional problem with that is that sometimes the manifestations of a DNSSEC validation failure are completely non-obvious. I'll give an own personal example was that I run a validating resolving server on my laptop. It broke
details don't matter for that, but the way that manifested itself was, I can't get onto the wireless network at the right meeting. That's how it manifested itself. It looks as if the DHCP client has gone away.
Yep.
So some of these things are not obvious. And something, if you're interested in playing with this and finding it out, is the root server's key signing key, if like the one and only true trust anchor, is going to be rolled probably next year. So if you're interested in playing with this, there's going to be a test bed where you can actually play with rollovers of the key signing key in a controlled environment, which is not going to break anything important, but you should try that to see what will then fail in your network when the key does roll over and you haven't changed the trust anchor. So it's useful to try that experiment, and I think it's useful for people who want to play in this space. The other point I want to make is about DNSSEC deployments, and I've got a very cynical view about this now, unfortunately, because ultimately it requires the kindness of strangers. So if you're in a position of actually publishing zone data, you're relying on the people who are doing validation not to screw up. If they screw up the validators, my zones fall off the network, and therefore bad things happen. And I've got no power over what those validating people do.
Well, that works both ways, yes.
Likewise,
Yep.
if you're doing validation, as you're in position, Paul, it's the other way around about. You're relying on the people that are signing not to screw up. And at the moment you're saying you're only getting a handful of support calls a week. I wonder what would happen is if, let's say, for example, it was Facebook that switched on DNSSEC validation and somehow screwed up the keys. I wonder what your position would then be about that from a validator's point of view.
Oh, well, I'll tell a very quick story. I was at Comcast for about 3 months when HBO was rolling out HBO Now, which was you don't have to have a cable subscription. You can just go on the web with your iPad and get your HBO content directly without ever paying your cable provider. They DNSSEC signed HBONow.com. The day they launched it, they screwed up and wiped all their signatures, so it failed to validate. So it made the Wall Street Journal that Comcast was filtering HBO Now from their customers. So if I'm willing to take that kind of heat to do DNSSEC, I think I'm pretty serious. And yeah, your other comments are correct. It is definitely kindness to strangers, though I will say, what would it be like if any person in the world could say something and have the entire global routing table affected by it? I mean, we'd never roll out a protocol like that, would we?
No.
Okay, thank you, Paul.